1.5, we have two main topics that we're going to cover today. Number one, CLT stands for combining like terms. Number two is the distributive property. Before we get to either one of those, we're going to go through some vocab when it comes to expressions with variables. So we see here 3x plus 8y minus 7. That's an expression. It has no equal sign. Each part of that expression is called a term. Terms are separated by pluses and minuses. So I have three separate terms here. My first one is 3x. My second one is 8y. And then you could argue that your third one is either 7 or negative 7, depending on whether you include that negative in there or not. I'm just going to count it as 7. So those are terms. When we have variables in expressions, remember variables, those are the things that are letters, right? Letters in an expression. When we have variables like x and y in our expression, sometimes those variables have what we call coefficients. The definition of a coefficient is literally the number in front of a variable. What is that number doing to that variable? What operation is happening there? James? Yeah, it's multiplying. So it is being multiplied to the variable. So in this expression, I have a coefficient for x, which is 3, and a coefficient for y, which is 8. Things in expressions that do not have variables are called constants. A constant is literally that, a number without a variable. Questions there? So we've got simplifying expressions, kind of like what we did yesterday, except sometimes we have to do a step called combining like terms. What are like terms? Terms are called like terms if they have the same exact variable, meaning the same letter or letters. Sometimes it's more than one. And, this is the most important part, they have to have the same exact exponents. So for example, let's look back at our example here. What's the exponent on this x variable? Does anybody know? We can't see it, but what is it? 1. Yeah, it's a 1. So the exponent there is 1. Same thing for the y. The exponent there is y. The exponent there is 1. So different variables, x and y, same exponent. We have to have both things be true for them to be like terms. When we do find like terms, we can combine them. That is how we are going to simplify some of these expressions. We combine them by adding/subtracting the coefficients only. And we leave the variable and its exponent the exact same. Any questions there? So very straightforward here. If I look at my example in letter A, I have 3y minus y plus 12. Like we just said, those y's have an exponent of 1 on each of those. They are the same letter, so we can combine them. We combine them by adding up their coefficients. What is the coefficient for that y right in the middle here? What's this coefficient? James? Yeah, it's a 1 or a negative 1, technically, because there's a negative there, right? So because we can't see it, we know that there's an implied 1 in the front of that variable. So really what I'm doing here is I'm going to add up 3 minus 1 to get 2, and my variable stays exactly the same. The thing that's left over, that 12, has nothing that we can combine with, so it's just going to drop down. And that is the most simplified form of my expression. Okay, moving on to letter B. Hopefully we can see, now I've got multiple letters, but as long as those letters are the exact same and those letters have the exact same exponents, we can call those like terms. So in letter B, my variables are mn to the 4th and mn to the 4th, which are the exact same. So again, I can add up -7 and -5 to get -12 and keep the variables the same. What do we see in letter C? Where are my like terms here? Jaden? Perfect. -8x to the second power and 3x to the second power. I always find it helpful to like circle or underline where my like terms are. So again, I'm going to add together those coefficients. -8 and 3 gives me -5 and leave the variable the same. I'm going to drop everything else down. Before we move on, there is one little tiny rule that we need to follow. When we are simplifying expressions, we always want to list our terms, right? Terms are separated by pluses and minuses. List our terms from the highest exponent to the lowest exponent. So the highest exponent in this particular expression, do we see? It's this x to the 3rd. That's the biggest exponent I have. So that one is going to go first. And then I'm going to go down the list. So -5x squared. 4x, remember, has an exponent of 1. And then that 2 has an exponent of nothing. That is the most simplified form of our answer. Any questions there? Okay, flip it to the next page. We're going to talk about our second topic for the day, which is the distributive property. We have probably already seen the distributive property many times before. The distributive property says that if I have something that is something that is outside of some parentheses, like for example, a times b plus c, then that's the same thing as me saying, well, I can distribute the a to that b, a times b, and I can distribute that a to the c, a times c. You really, like a lot of the times we'll see these little bridges to indicate what you've multiplied together. Have we seen this before, maybe? Okay. So the distributive property states that you can multiply a term outside the parentheses to every term inside the parentheses. So if I look at letter A, I have a 5 on the outside of my parentheses. I'm going to draw my little bridges here to show that I'm multiplying 5 times x, which is just 5x. And I'm multiplying 5 times 7, which is 35. Sometimes we have negatives that we have to watch out for. The negative moves along with that coefficient in the front. So if I have a -3, I'm making sure to multiply everything by -3. 2y times -3 gives me -6y. And then -3 times -1. 2 negatives make a positive. Don't forget you have a plus sign there in the middle. Any questions on that? Sometimes they like to be tricky and just like write things weird for no reason. So sometimes you'll see something like letter C, where the 12 is at the back. I don't know why it's in the back, but we're not going to treat it any differently. We're going to take that 12, we're going to multiply it to the 3. 12 times 3 is 36. And then we're going to take that 12 and we're going to multiply it to the -1/6 t. Do not forget this negative right here. Very important. What's 12 times 1/6? Jaden? Yeah, 2. So I have a negative 2t. Remember my rule from last page? We want to write things in terms of the highest exponent first and the lowest exponent first. I'm going to flip-flop these so that the 2t is in the front. I'm not going to be taking points off for this just yet. Eventually, I will be picky. So just get in good habits right now. Letter D, last one. I got a negative on the outside of my parentheses. What is the actual, number that's there? It just says negative with no number. So what is the number? Ashton? Yeah, it's a 1. Remember, if there's no number there, it's an implied 1. So again, I'm going to multiply this -1 to the -3. 2 negatives make a +3. -1 times -x, positive x. And then we should probably flip-flop this one too, just so it's proper. X plus 3. Any questions there? Now we're going to put it all together. So distributing and combining like terms all at the same time. In letter A, we should always start with our distribution if we have it. So I see that 2 times w minus 5. That's what I'm going to do first. 2 times w gives me 2w. 2 times -5, don't forget that negative, minus 10. Drop everything else down. Now you might want to underline, box things in, highlight, whatever you got to do. We're finding like terms. Where are my like terms in this expression? Braden. Perfect. Remember, add the coefficients, leave the variables alone. That should be 8w. What else is a like term here? Braden. Yeah, 9 and -10. So 9 minus 10, -1. Simplified. Perfect. Questions? Last one. I got multiple things here that I am distributing. So let's take care of those first. 1/2 times 6. Remember one of our multiplication words was of? This is a circumstance where I like to think of multiplication as of. What is 1/2 of 6? 3. What is 1/2 of 4m? Perfect. My other distribution, let's drop the rest of this down before I start talking about distribution. My other distribution is right here. Remember that implied 1 in the front? Not going to forget about that. I'm going to distribute that to the 8. So -1 times -8, positive 8. -1 times -5k, positive 5k. Okay, what can we simplify here? Where are my like terms? Jaden.
The like terms are 2m and -2m, and then 3 and 8, and then 3k and 5k.
Let's do triangles, why not? Okay, so let's take it step by step here. 2m and -2m, what does that become? 0. Do we have to write that? No. So let's cross them out. We're good there. 3k and 5k, what does that make? 8k. Remember, add the coefficients, leave the variable the same. And then 3 plus 8, 11. There we go. Any questions? We did it.